Oh, here we're recording. I guess it doesn't send you a link. Okay. Um, hey David, how you doing?
Good.
Um,
How are you, Thomas?
I'm good. So like I brought you here today to talk like on a number of topics. I'm thinking to start out with like AI, since that's kind of like what you kind of work with, or um, and we can go from there. So do you want to start just by giving your background, like academically and professionally, and then yeah.
That's great. So AI is a huge topic. I've worked with it in a variety of capacities. As for my background itself, so I did my undergrad in engineering science at University of Toronto, and I did a master's there as well in electrical engineering. And basically, from the time onwards, starting my master's, I had started to focus in a subfield of neuroscience called computational neuroscience.
Hmm.
Uh, I carried that through with my PhD. Still working in that field on modeling um, biological neural networks of
Hmm.
various scales, and did a postdoc at Boston University, and eventually made my way to Neurable, which is where I'm currently working.
Okay. And right now you're working on some headset application or something like that?
Yeah, that's right. So we're building basically the algorithms to make devices capable of sensing brain activity. So right now, our current application is a pair of headphones for monitoring focus, and we're in general interested in kind of building out a broad platform there.
Hmm. So going more into AI, what are your thoughts on like, I guess, ChatGPT and the newest like emergence in technology when it comes to AGI and stuff like that?
Yeah, so I've been following it pretty closely. In general, I think it's something that's going to be very transformative, and I also think it's something that we need to make sure is rolled out properly and in a safe fashion. For one thing, there's just the aspect of AI transforming human societies, greatly empowering individuals to accomplish more. And then on the other side, there's the whole AI safety factor. So the idea of how do you like if autonomous AI becomes increasingly advanced, and how do you kind of steer it so that its values are aligned um, with what's good for humanity. Um, and this is especially an issue when you get into the ideas like recursively self-improving AI. So systems that um, are able to adapt and modify themselves beyond kind of the more simpler forms of machine learning and AI that we use now, where we just give it some training data and have it learn to interpolate within that data set.
Hmm. So th this can get us into like our main topic or where I've been thinking on focusing on, which is consciousness. And we can get into like AI consciousness after, but at first, what do you think consciousness is in like biological systems or in general? And we can go from there. Like, how do you think consciousness functions and uh, what is it?
It's a very tough question. I probably don't have uh, an answer that's um, going to be satisfying there. Um, I like starting with the viewpoint of um, like consciousness is the only thing that we know. It's a subjective experience that only you or I personally experience, and it seems to be dependent on things we know about our physiological state.
Mhm.
Um, so if we know we go to sleep, right, we know that our consciousness uh, will be there'll be a disruption, a discontinuity in the stream of consciousness that we're perceiving. Um, but beyond that, it's not really clear why um, the universe or biological systems as we understand them should exhibit this property.
So do you think the biological systems evolved this capacity because it was evolutionarily advantageous, or do you think it's just like an epiphenomenon of uh, evolutionary processes, or do you think it's something more fundamental to nature, like associated, connected with matter in some way? Um,
Yeah, I think I tend to fall more in the epiphenomenon camp. I'm not really, it's not really clear to me what the evolutionary advantage of it would be. Um, having this um, window into the world that kind of rides along with us as we go about our life. Like I would think that you could make accurate decisions in the absence of that as well.
Yeah, maybe it's circular reasoning. I'm not sure, but the way I thought about it, if it is evolutionarily a result, I would think it's because we I mean having a subjective experience makes you care more about the outcome or try harder to survive if there's something going on. If you can actually feel pain, but I guess we could all be like pea zombies, and then do the same actions, but then that wouldn't make any sense, really. I guess I'm not sure how to think about that. What's your thoughts on if it has any uh like so you think consciousness has like zero utility in like survival, or what would you say?
I think you have to ask then, how does consciousness impact behavior? And you can imagine that there could be um, an entity that has its own internal representation of the world, um, and it uses um, that internal model to guide what actions it performs, and that model could exist with or without a subjective experience associated with it.
Yes, I agree. But my question is more, if it is merely an epiphenomenon, what is the causal mechanism that uh, makes it emerge? Or um, can we get into like the difference? I don't know. This is sort of applicable here. Maybe the difference between like strong emergence and weak emergence. Like where do you think like do you think consciousness is like a thing on its own? Like how does it connect to matter? Um,
So I don't think we really know, right? Like, in a clockwork universe, you could have, there's no reason to suspect that consciousness would emerge from individual particles that just behave like clockwork. If So I think this is kind of getting at the idea of associating some like quality of consciousness with matter, and if you perhaps if you add that ingredient into the system that is the universe, then that might be necessary for explaining it.
so like some form of panpsychism or something.
Yeah, yeah.
Okay.
To me, like I think you would need that, right? I just don't know how, if you had individual building blocks that um, um, were simply like clockwork, how you could have an emergent property come out of that.
Does quantum element change that though? If you're not thinking purely deterministic, does that change your hypothesis, or how you would think about consciousness?
I could, I guess, I'd say maybe it's kind of a bit of a separate dimension. So you could have quantum mechanics introduces an element of randomness into the universe, right? That doesn't necessarily have to introduce an element of consciousness. To
Exactly.
You gotta have maybe like four quadrants, right? Um, um, like randomness and no randomness, um, those could be two types of universes, and then another two axis of division could be like the conscious and the unconscious universe.
What do you think gives rise to consciousness in those consciousness universes? So you're saying like a subunit of matter would like possess something we call qualia, and then if it's arranged in this particular like way, then you have information processing and complex consciousness, and otherwise then you just have like units of like low level consciousness. Is that what you would say?
Yeah, I think so. Like for one thing, we don't really, we have to accept like there's some things we understand. There's a lot of things we understand about the nature of matter, right? But there's also a lot of things we don't necessarily understand about it. So that leaves a lot of room for like, you know, the existence of qualia there. And you know, as far as how they come together, I think this kind of gets into the realm of thought experiments that you could run and you know, try to understand your own conscious experience that you're having right now. Like what changes to the matter that make up your body would affect your conscious experience.
Mm-hmm.
You know, would swapping out with silicon affect your conscious experience? Would duplicating every atom in your body shifted in position, but otherwise exactly the same, how would that affect your conscious experience? And would you be the original? Would you be the duplicate? If you were to freeze your body right now and then reassemble it, or like, you know, disintegrate it even and then reassemble it 10 years in the future, right? Would you be the same you or not? So
Could you not argue that would be the same thing every time you go to sleep then?
yeah, it could be.
Yeah. Yeah, like are we the same? Like because presumably if someone's in a coma for like 10 years, they're still the same consciousness when they wake up. But
Yeah.
if you're saying like you possibly not, then every time you go to sleep, are we just like the memories that are stored make us feel like we're the same consciousness because the contents of consciousness are the same, but it's actually not. But what difference would that make anyway? It's all the same to the system once it realizes itself, right?
Mhm. I think I understand what you're getting at there, and it's I've thought along those lines as well. I'm probably going to butcher the explanation of how I'm thinking about it. Um, but I think basically, if you think about the experience you're having right now,
Mm-hmm.
um, there's the immediate sort of sensory inputs that you're receiving, and if you're just receiving those without having any memories, right? You'd have no idea who you are. You'd just be like, oh, I'm alive, I'm experiencing stuff. Um, but it's really your memories that make you you. So when you are experiencing these sensory stimuli, and then you have memories of previous sensory stimuli that feel, and you know that these are familiar to you. Um, like you look in the mirror and you see your face as opposed to somebody else's face. You know how your body feels. I think this is kind of the root of your um, what makes you you as opposed to somebody else. And if you were to like strip that away from everybody, then we'd kind of all be the same. We'd all just be like little islands of consciousness experiencing stuff.
Do you think like at like fundamental level, um, when like that when you said islands of consciousness, it made me think of something. Do you think there's only one? Maybe thinking of it in a field is too spooky and not scientific. I'm not sure, but is there one field of consciousness and then there's different locations in consciousness and you're a location, I'm a location with different contents because we're in different positions in space-time and we have different brains that are allowing the information processing to occur, but the consciousness itself is like is am I speaking some weird language or does that make any sense?
I think so. Let me try and see if I can um, tell me if I'm understanding correctly or not. So, um, we exist obviously in different points in space, um, and you and I, we both are having a subjective experience, but we're receiving different sensory inputs. Like I can see you and you can see me, and then also you and I both have different memories. So I remember how your face looks through the screen, how it looked 10
Mhm.
seconds ago, and same for you. So there's some continuity there. Another thought experiment you could do though is you could imagine like what would happen if we shared memories. I remembered how your body felt and vice versa. Um, this would kind of slowly start to melt away that like those the space between the islands of consciousness, and what would our subjective experience be like? Would we retain individuality? um
Mhm.
I think maybe we wouldn't, right?
We wouldn't maintain individuality in the case where, sorry, I want to make sure I follow that.
Yeah,
Say that again. We wouldn't maintain individuality if what?
if
Like,
we had access to each other's sensory inputs and also to our memories.
but
Like
that
I think,
we would have to be like our brains would have to be connected through some system in that.
yeah, however you'd
Yeah.
facilitate that,
Okay,
right?
yeah,
Like,
yeah. So would you think okay, so you've obviously heard of the thought experiment of like the teleporter, like if if we had like some teleporter and then it reassembled some atoms somewhere on Mars and then destroyed us, would that be the same consciousness on the other side, or would it be like a twin, a clone, like not actually? Would there be no continuity in our experience, or would there be continuity in our experience?
and I think that all comes down to memories, right? Like this is where stuff gets weird. But I think thought experiments can guide us. So, um, if you imagine the scenario in which um, you disintegrated yourself on Earth and assembled yourself on Mars, there would be a you on Mars that is having subjective experiences. It's experiencing its body and it remembers how its body feels like. So it would be you, I would think. Um, and your subjective experience would continue to exist over there. And then you ask like what happens if you don't disintegrate the original and both exist? Then the universe would have two Thomases. And
Then what happens? What this like because then you'd have two different streams of consciousness, presumably they wouldn't be connected, right? So
yeah,
uh,
so you'd start to diverge at that point, right? But it's a question like, um you then ask, well, for one thing, if you were to just like an external observer observing both these Thomases, right, you'd see there's two Thomases. They both think they're Thomas. They both,
yeah,
are the same, feel like the same person. Um, and then what's the subjective experience like for each one? Well, each Thomas also feels like Thomas. Um, and it's nothing unusual. They just see a duplicate. It's as if you were um, like watching a movie of yourself, um, from that was recorded, and played with a 10-second time delay. So you'd see
of
yourself
course,
in that movie,
of course. Like when we take
but
a picture of ourselves, we're
yeah,
looking in the past. That's no longer us. That was a representation of us at a single point in space time. Yeah, I
yeah.
see.
But I think this is the fact that you would see this other person who would have at one point been you, but is now different. I think the really cool thing about this is that, um, you have to ask like, um, at one point in the past, you were you, you had your conscious, and you have to ask like kind of which Thomas does that past Thomas inhabit from a subjective point of view? Is it one or is it both? And I think the answer is both. But then the implication of that is if you are inhabiting two Thomases at the same point that are now separated by like different islands of consciousness, then maybe all humans are like that as well. We're all kind of the same subjective like entity experiencing subjective things. It's just like we're now separate because we you know, our sensory streams are not are different, and our memories are different.
So do you think when like we die or biological organisms fail, consciousness still exists, but not in that location, and there's no memories left, there's no information processing. So basically, unconsciousness is there's pure experience at the level of the universe, or is there like no experience? To us, it would be the same. We would not experience it. We ourselves would feel like there's not experience because there's no information processing to have memory to acknowledge that there's experience. But do you think there's experience always, like when we're sleeping and we just don't remember? Or like that's not quite synonymous with being dead, but you know what I'm saying.
I think it probably goes away, like when you're sleeping or after you die. I think it goes away, or at least your you know, that island that is you goes away. Your memories are lost, but there's other conscious entities in the universe. So consciousness continues. There's like this
The
kind of gets
question
into,
is, if there's no life left at all in the universe, is there still consciousness without information processing or memory?
sorry, if there's no life in the universe,
Yeah,
is there still
consciousness without the information processing element or memory that,
um
and if so, is that
well,
just,
I guess if there's, you know,
yeah.
I guess it depends how you define life. Like if there are computers, right, that are doing information processing, you know, maybe I think it has to
But
have a
we don't assume yet, or maybe
yeah,
some people do, but we don't assume yet that those are conscious, right?
right.
Um,
Um, yeah, I think it has to have like as long as there's some sort of there's matter that has this property of consciousness, and there's some sort of sufficiently complicated assembly of that matter that has uh, the right properties. So things like feedback and so on, I think are important. Um, you know, I think there that could be capable of generating consciousness. Um, I don't think we have to necessarily have to be a biological substrate, but I think there are certain like there's a really like Goldilocks zone for things that will exhibit consciousness and not like. And as an example, your brain, it's no less complex when you go to sleep. At least anatomically, it's no less complex, but
mhm.
just like a
And
tiny shift.
we do dream for part of our sleep, so there,
That's true. But if you go undergo anesthesia, right, like you're
yeah,
not conscious, but
or in deep sleep, yeah.
yeah.
So, would you say, where was I gonna go with that? It in the case of like subatomic particles or just whatever, do you think those units of consciousness have have if they have a unit of qualia, does that mean they have an experience, or they don't have an experience because there's no information processing and memory to be tied to that experience? And if you need information processing and memory to have experience, what is experience then? Like is experience like it's the one thing that can't be an illusion, but if you can't have raw experience without information processing and memory in a certain way, how is experience an entity of itself? Yeah.
Well, yeah, I think you could ask, does your brain under anesthesia have an experience, right?
Yeah, I would say it doesn't, but
Yeah,
I could just not remember, right?
that's true also, yes.
Yeah.
But yeah, I think you need more than just, yeah. So I think on the one hand, if I were to say I were to type of a computer program, right? Um, and I were to include in that program, um, you know, a mathematical model of the Newtonian universe. We have particles bouncing around. Um, I would be surprised if consciousness could emerge from that model. Um, Another example that I really like is if you imagine you had like a room full of physicists writing on paper out the dynamical equations of the universe. Um,
Like an algorithm for consciousness or something.
or even just like so we have a mathematical description of physics, right?
Yeah.
And we
Okay.
see um, the universe is playing out um, those those dynamics. So all the particles in the universe are following the rules of physics. And I think there's something special about those particles that allows them, when they form complex assemblies like humans, it allows these humans to experience um, consciousness. If you were, though, to um, um, apply those rules of the universe to a different substrate besides matter, so like one substrate could be, as I was saying, like simulated in a computer, another substrate could be um, markings on pen and paper, where there's markings that describe the position and velocity of each particle.
Then you don't get the same result.
Yeah, because there's
And
something missing there.
what would you say that special thing is? What would your intuition be? I know we don't know, but I'm just asking you since you're providing that kind of
Yeah. Um, so um, it's a good question. I feel like that's kind of, we create the concept of qualia, right, in order to answer that question, but it's just a word, um, kind of like ether or something, right?
well,
So,
why would it be like exclusive or special to like biological organisms and not be able to be replicated inside like silicone or some other.
oh no, I don't think it's special to biological organisms. I think it's special to the matter in our universe, though.
No, but you said if we try to like um,
Right, that's true.
describe it inside a
That's true.
computer, so is that not the same thing? Because our computers are still made out of matter in our universe. They're not
Yeah,
something other than matter,
yeah,
right?
yeah. So maybe like the unique properties of our universe's matter would propagate up and somehow allow those things in our. It's kind of like a simulation within the universe, right? If the universe, you assume the universe is base reality, then you can run a simulation in the universe. And on the one hand, maybe it's the case that um, if you assume the universe possesses qualia, maybe that qualia will be conferred to your simulated universe, or maybe it won't. I don't know. I kind of feel like in the example, especially of physicists on pen and paper simulating, running a simulation, I feel like that probably wouldn't bubble up, and I don't think, um,
If
you know,
it doesn't bubble up, then why does it bubble up in our case? Like you still have to be able to explain that difference,
mhm.
right?
Yeah, it could be, I guess, a difference in the implementation. Um, so maybe it's the case that you could have two systems that are doing all the things that humans are doing, like processing information, making decisions. Um, and if you implement it, there's a bunch of like checkboxes that need to be met. So one checkbox is that it needs to exist in the universe with qualia. Another checkbox is that it needs to have a particular implementation. So maybe, for example, a silicon simulation could do it. Maybe like organic molecules can do it, but maybe pen and paper, like physics calculations can't. Or maybe if there's
Yeah, well,
yeah,
I would think that makes sense because if you just write things on a piece of paper, there's no like physical process that is changing that paper. Yeah.
and it could be like it could be related to quantum mechanics also. Like if you imagine doing a Newtonian simulation um, in a computer versus a simulation where somehow you're able to get randomness into that simulation that was tied to quantum mechanics, then maybe that would make a difference, right? I don't know about that, but like it's
Well,
uh,
do you know anything about like Roger Penrose's idea of like microtubules in the brain, or know anything about that?
yeah, I've read about his idea there before. I think it's fascinating. Um, you know, um, yeah, I don't really have a strong opinion on it either way.
Could you
Um,
explain it though, or you're not too familiar with it offhand?
yeah, so I think there's two aspects to it, and it's been a while since I've gone over this, but one is the idea like there's the question of is it possible that elements of quantum randomness can um, can have a meaningful impact on brain dynamics. Um, and that's kind of where the microtubules comes in. The idea that they're small enough that quantum mechanical effects can influence their behavior, which can in turn um, ultimately influence the behavior of neurons and organisms. And then the other aspect to that is um, so um, I don't remember this perfectly. I think so. Penrose had this idea that there's certain problems that humans can solve, and I think it had to do with like the idea of Turing completeness. So I think it was something like if you don't include quantum mechanics, then there's certain problems that humans can solve that we shouldn't be able to solve because they're outside the bounds of what Newtonian mechanics can give us. Um, and I think that was his motivation for saying, okay, we got to add something to this. And then he eventually came across this microtubules idea.
Yeah, from some anesthesiologist, right, or
Yeah,
something
yeah.
like that. Yeah. Okay.
So I
Um.
think it's a fascinating hypothesis. Like I hope they can, eventually. That'd be really cool if they could demonstrate that it had a meaningful impact. And I don't think like I think there's arguments against it. Like I know Max Tegmark has done some stuff on like calculations showing that it shouldn't have an impact. Um, but
Have you heard much about the a kind of entirely different starting point? Like, I guess it's called like idealism, where basically consciousness is everything, and like we have to explain um like objective like matter more, like consciousness is the starting point rather than the other way around, rather than like it's just a
yeah,
completely different starting point. Like I think Bernard what's it, Kirchhoff, I don't know his name offhand, Bernard something, he's a computer scientist um from Portugal. I think he works in Netherlands though. He talks about this idea, and he's got the most compelling argument for it, but it's still kind of on the fringe of in neuroscience and physics. Um, but what are your thoughts on idealism and how it could, like, how plausible is it? Um, what do you think that, like, do you have any thoughts on it basically?
um, yeah. So I think it's kind of like I think therefore I am Descartes
Yeah.
idea. Um, and I think it's reasonable. Um, and it kind of also gets into the idea of what is what is reality, right? We know that um, we're experiencing stuff, and that stuff is it's not random white noise that we're experiencing. There's a consistency to it. And there's a certain models of reality that are really good at explaining that consistency. And those models are essentially our representation of the world, how our brain understands the world.
So kind of like the Donald Hoffman kind of icon. Have you heard his
No, what's that?
It's basically like everything is um like if you click on a computer screen, you have like the different icons that pop up that make it easy for like you to like interact with the computer, but really it's just a bunch of code and numbers. He's basically saying reality is fundamentally the same thing. Like nothing is what it really seems, but because we're biological systems, our brains put everything together in a way that makes sense of everything, but really nothing is objectively how we experience it from a first person point of view. Yeah.
Absolutely, it's like a pilot in a cockpit, right? And the plane has all sorts of sensors connected to it, and stuff has been assembled in the cockpit in such a way that the pilot can interpret all those things in a meaningful way, as opposed to like having to directly um, uh, process that data of like wind speed and altitude and that type of stuff, radar. So I think our brain is doing that job for us, and that's kind of what gives rise to our experience.
Mhm. And going to AGI again for a bit.
Hmm.
Do you think like given everything that's happening with like large language learning models like ChatGPT, um, how can we say when something is really passing the Turing test? Because for a layperson, I would argue that it's already passed the Turing test. Like, unless I'm doing something extremely weird to throw it off to find it's not human. I could be convinced I'm speaking to a human being for quite some time. Um, so so what are the parameters for like a Turing test? And does it pass the Turing test? Not is it conscious? We don't know that, but it is it as sophisticated as a human for all intents and purposes. I know it has its limitations and it can hallucinate, but so can human beings. Human beings can have strokes and not make sense. And so, does it pass the Turing test? Yes or no?
So I want to say a few things. First
Okay,
of all, I was talking to one of my friends about this, and I was telling him that sometimes when I'm writing emails, I'm worried that people will think that I've drafted the email with um, ChatGPT,
because you're so
because
logical or something, or
because ChatGPT has a certain way of writing now, and I
yeah.
feel like it has a style, and I feel like if you do anything close to that style, then you run the risk of people thinking that you're ChatGPTing them, and it's also that style is kind of infectious. Like I find if I use it more, like I start to write in that sort of like chipper, cheerful style as well. Um,
Yeah.
so you know, that's one thing, and because of that, I think it has implications for Turing test because now I know the ChatGPT style of writing. Um, I think I could probably distinguish it from a real human now having used it.
Hold
But
on for a second. But
yeah,
is that any different from distinguishing between two people in their style, right? Like you and I
no,
might
no,
write.
I think it's the same thing. But it allows me to kind of cheat and get around the Turing test, right? Because I could
No,
probably
because essentially you're just saying, "Oh, I know that's not Thomas writing that; it's Bob writing it." But it doesn't tell you whether it's human or machine. I mean, it only does in your case because you know what the machine writes like. But in the case you don't know what the machine writes like,
so if we
you
were
see
to
what
go
I'm
back
saying?
to when ChatGPT first came out and I didn't have any experience with it, I think it would pass the Turing test.
Yeah. Okay.
Unless like I were to find some way to like make it bug out and so obviously not human, but for standard conversations, I think it's really good.
Yeah. But human beings can bug out too. You only need to be around like a few drunk people, and then you'd be like, oh, okay, maybe these people don't pass the Turing test either.
Yeah.
So I don't know. Did you want to touch on anything else, or do you want to wrap up? I don't have like any more specific questions on those two like subjects. Do you want to get into like I don't know academia and like industry differences, or
Yeah, yeah,
sure?
that sounds like a good topic to go into.
Okay.
Um,
So
so you want to know my thoughts on?
yeah, your thoughts, your general thoughts. I don't have like specific geared questions, and I don't want to ask anything too controversial either. So I'm just
Sure.
letting you. Uh,
Yeah, so I think um, there are two very different entities. I've been in both, um, and they lead you to a different lifestyle, and um, I think it's very personal which one you prefer. Um, I initially was interested in academia, because I realized there were specific questions that I wanted to pursue. I could only pursue them in academia. Um, and then later on, I kind of realized that, um, you know, academia to some extent, it's largely, what you work on is largely determined by what you can get funded to do. So you don't have not necessarily have absolute freedom in academia either. Um, and so, and I realized also that, I could pursue things of interest, um, to myself as hobbies. Um, and that I think kind of combined with the desire, as I feel like when you're in your teens and your 20s, you're kind of more idealistic, but then, um, as you get older, you kind of gravitate towards more practical things and wanting to like build stuff in the real world. So I think those two things together, um, were what made me gravitate towards industry, like the desire to actually build something that'll have a direct impact now as opposed to, in 100 years or something.
yeah. What were your aspirations originally before you switched? Like, what kinds of things did you want to solve, and how did it change? And what do you think some of the more practical things are now that you're working on, or in general? It doesn't necessarily need to be what you're working on specifically.
So in general, I'm really interested in, bringing brain computer interfaces, neuroscience, out of the lab. Um, and that's kind of what landed me at Neurable. Um, I'm just in general kind of have the belief that, this is the century, maybe in the next few decades, in which we'll make a lot of strides in terms of understanding the brain. Um, and it's kind of like the last frontier for, maybe not the last frontier, but like a major frontier for understanding ourselves. Because I always had a lot of curiosity about um, the universe and the nature of mind. Um, so there I was doing, computational neuroscience, so modeling, of biological neural networks, and for me, kind of the long term dream is to understand, um, on a computational level um, how our brains work. And it's incredibly complicated, and maybe, intractable from, depending on the approach that you're taking, but um, I still find it interesting, and it's just a lot of fun as well. Um, so I think that's kind of where I am now. I'm kind of in a middle ground. I'm still working in neuroscience, but I'm in industry as opposed to doing research.
Mhm. Does part of your industry work involve doing some research too as well, though, or are you just creating, helping create products without doing any like data on it?
So we go through phases. Right now, we're in a much more, um, getting product launch, getting things done phase. So we're taking science that we've done in the past and pushing it into products. So this is where for myself I'm learning how to make things happen, and like solving all these it's problem solving. That these are like organizational and human problems and software problems as opposed to science problems. And in the past, though, we've been more dealing with fundamental science. So how do you using EEG, how do you get insights about internal cognitive state of a person, and what types of insights can you get out outside of the lab in a noisy environment. So that's kind of the more science driven approach.
And the current thing you're working on is trying to understand, I guess, the electrophysiology of like focus and when somebody is like paying attention, I guess, versus
Yeah.
not. Do you want to talk a little bit more about some research you did prior to going into industry, whether it's epilepsy or development of like that Alzheimer's video game or something? Do you want to get into any of those topics or?
I can talk quickly about the epilepsy stuff if that's of
Sure,
interest.
sure, okay.
Yeah, so there we were. It was a study on basically trying to understand how when somebody gets a head injury, what we typically see is after a number of years, if it's a sufficiently bad injury, people can develop epilepsy from that. And what we were trying to understand is, what are the mechanisms that underlie that? And
Like
essentially,
brain injury with lesions or without lesions?
I'm not sure. I think like essentially there has to be some sort of trauma, like traumatic brain
Yeah,
injury
yeah.
that causes these like processes, that regenerative processes, to turn on. And in addition to healing the tissue, they change the wiring a little bit. And this wiring, these wiring changes gradually push the brain into an epileptic state. And that's really something we were trying to find out. But kind of serendipitously at the same time, because we were looking on these very long time scales, what we found is that there's actually a circadian component to this. And in particular, this is a study done in rats. They found that rats that had were not epileptic, but were they had an injury and they were going to become epileptic eventually. Those ones had some anomalies in their circadian rhythms. So and these anomalies were
Like sleep-wake cycle or something else?
it was they actually had normal sleep-wake cycle, but there was a specific part of the brain where their circadian rhythms were not normal. And the exciting thing about this was that it only happened in the rats that actually went on to develop seizures, because sometimes the rats would not have epilepsy. It wasn't like 100%. When you get a head injury, like you're not always 100% going to get epilepsy from it. So it seemed like it's correlated with your odds of getting seizures eventually. So this then this suggests that we could have something that has diagnostic value.
Is there any specific brain regions that were most, I guess, correlated or connected with that kind of issue? I guess temporal lobe is what a lot of people hear about in like humans when you're talking about like simple partial seizures. Was it kind of similar in like rat populations or?
Yeah, I think this phenomenon could happen anywhere. Like you can get epilepsy and
yeah, really anywhere. Yeah.
Yeah. And my theory is the mechanism is essentially when you have a brain injury, I was mentioning there are changes that happen. And these changes gradually cause you to develop epilepsy, changes in the wiring and so on. And this is just my theory, but I think it's possible that if you have an injury, not only does it disrupt or it causes damage, but it disrupts these circadian rhythms in a particular part of the brain. And because things are kind of out of phase
Mhm.
as a result of the circadian damage, maybe that has a reinforcing effect and causes the like it alters perhaps how synaptic plasticity balances change over time. Because if over a long period of time you have like electrical activity patterns of electrical activity change, then circuits are going to try and rewire in response to that. And maybe um, this altered circadian rhythm then actually plays a causal role in the rewiring that that leads to epilepsy. It's just a theory, and it is based on the fact that we saw this finding in this rat study that was done, but it's unclear. Um, and we haven't had any way to test it yet, whether it's
And
actually.
epilepsy, at least in human populations, is defined as a seizure that happens more than twice, correct? Like anything before that is just isolated seizure or something like that.
Yeah, it has to be spontaneous recurrent seizures.
Okay, and it, is it that some forms of epilepsy are did like neurodegenerative and others kind of self-resolve, or they kind of all lead to the same path? It's just a matter of like degree, I guess, severity.
Um, that is a question for an epileptologist. I'm not that familiar with
Okay,
the
no
different
problem.
subtypes, but yeah, in general, like seizures tend to be self-reinforcing. So if you have one really bad seizure, it will increase the likelihood that you'll have a subsequent one. If you have like a really high fever, that can
Yes,
induce a seizure.
like
And
febrile seizures, yeah. But how come like some people can just have one seizure? Let's say they do a lot of drugs or something, and then presuming that they stop doing drugs and
yeah,
they it doesn't happen again, and other people develop this kind of reoccurring, just spontaneous. Is there a difference in like gray matter or something in those people, or like it, is there some?
so
Yeah.
I think um, a seizure is a state of neural activity. And you could ask, like, if you have some healthy tissue, right?
Mhm.
Um, how could you push it into that state? Um, and one of the ways you do this in the lab in like tissue recordings is you change the balance of ions outside of the neural tissue, and that can push um, if you have like a culture of neurons or something on a dish, you can push them into a seizing state by changing the balance of ions in that dish. Um, and there's nothing innately epileptic about that tissue. So that's one way. Is that I guess you could imagine if temporarily someone's physiological state changes. They still have normal wiring in their brain, but they have a really high fever, or they take some medications that induces um, a chemical state that's very favorable to this type of seizing activity.
Okay.
Then the other approach is if the wiring changes, um, and then in a perfectly, you could just have seizures spontaneously happening.
Hmm. Um, yeah, I think that's all the topics that
Okay.
I have. Is there anything else more you'd like to discuss, or is that
Um, I think we covered a lot of stuff.
I think
It
we
was
covered a lot of
good.
stuff, and that's good enough for now. I'll stop the recording, and then we can say goodbye off air and talk a little more, but just end it here. And
Yeah,
thank you for your time and everything. I really appreciate it. And
pleasure, Thomas.